Okay, magandang umaga po mga kawerpa. Good morning po sa inyong lahat. Ganon din po sa ating mga viewers sa Facebook Live. Actually, naka-ano tayo sa Facebook Live, no, mga kawerpa. Good morning po. So, welcome to Marina's Powerhouse Team Review and Training Center. So, this is Kuya Reg, no? My name is Engineer Reggie Marinay, no? So, of Powerhouse Review and Training Center, no? So we are MPHT Review and Training Center. So MPHT, which means Marina's Powerhouse Team Review and Training Center. So we welcome everybody for this live stream at Facebook. This is a live lecture at Facebook. Today is, what's the date today, partner? Friday, August 28. What is the time? Around 10 a.m. no, in our watch. Okay, so to our non-Filipino viewers, okay, okay, hello, hello, okay, so, esya na po kayo, ganyan talaga, pagka live, okay, meron tayong mga counting, mga technical problem, okay, check po muna natin yung ating mga audience, okay, gusto natin makita ang ating mga kasama, no, sa ating Zoom class, so, here are our participants for our today's online lecture. This is what we call the Study of Electrical Engineering, the Filipino way. Okay, so may I ask Mike? Mike, do you hear me clearly, Mike? So that our viewers may also see, no, that we are conducting a live lecture. Okay, so pakita mo anak yung mga audience natin. Makikita na sila. Okay, so Mike, do you hear me clearly, Mike? Hello, Mike. Thumbs up nga kung maayos ako naririnig sa iyong lugar. Ayaw mag-thumbs up ni Mike. Okay. Si ano po ba? Si Sir Silva Aristelo. Ako po ba'y nakakarating ng maayos sa inyong lugar? Okay, si paring Leo, nandyan. Okay. Leo, do you hear me? Okay. Si Sir Joey Garcia is our early bird. Okay, so siya ang pinakauna sa ating Zoom class. Okay? So what is the advantage, no, na kayo ipapasok sa Zoom class, no? What is the advantage? Okay. So you will be receiving a certificate, no, if you are joining to our Zoom class. Okay, whether you are a Filipino, you are American, you are European, wherever you are. Okay, so this is a Zoom, this is a pre-lecture via Zoom, no? So you may visit or you may see our Facebook, the Marina's Powerhouse Facebook account, no? You will see there the Zoom ID so that you can come in. So this is a first come, first serve basis, no? How we wish that we have so many audience, no? We have around 500 audience. That is our maybe now an impossible dream. Okay, but we will try to reach there. That's our target. Because the next capacity of Zoom is we only have 100. We avail the 100 participants per month. No? We are paying for this, no? And then the next slot would be 500 slots. No more 200, 300, 400. So from 100, we'll go to 500. How we wish that we have those number of participants, no, all over the world. No? Okay, so good day everybody. So magandang umaga po sa ating mga kawerpang Pilipino. Okay? So to our non-Filipino audience, we welcome you to, we call this as Study Electrical Engineering the Filipino way. Okay? To our non-Filipino friends, so please bear with us. Of course, I'm a Filipino, so I'll be speaking in English, but I'm not that fluent in speaking the language. We'll just do this for you. Let's say you are American students, you are European students, you are from United Kingdom, so you may also understand me. Okay, so although I don't have that high efficiency in speaking the language, I just have a little on my pocket. Okay, so okay, everybody, are you ready to listen? But do not worry, to our non-Filipino kawerpa, don't worry, we'll try our best for you to understand the lecture. You can also get this, okay, this lecture. This is a very long program of our Review and Training Center. Okay, again, the name of our Review and Training Center is the Marinais Powerhouse Team Review and Training Center. Okay, so I'll try my best to speak the language, to make it in English. Then from time to time, I'll be speaking a little Tagalog. Okay, so that our Filipino friends will understand this also. Okay, but don't worry, I will speak most of our lecture here will be in English. Okay, so let us start our discussion with direct current circuits part 2. So the DC circuits part 2, okay, sa ating mga kababayan, okay, mag-raise hand lang po kayo mga sir ha, nakamonitor po ako sa inyong lahat. Kung mahina po ang dating ng sound ko sa inyo, mag-raise hand lang po kayo. Okay? Kung may problema po sa inyo, kung makikita namin lahat kayo nagtataas ng kamay, ibig sabihin may problema sa side namin. So mahirap po talaga itong aming ginagawa. No? I think tayo lang ang pagtingin tayo sa YouTube, tayo lang ang gumagawa nitong ganitong sistema na live lecture. No? With the audience, nasa Zoom class, no? So mas madali yung magre-record kami in the studio or in a small room, so that's easier. But the difference of this, you are in the Zoom class, you will get a free certificate and you will have a chance to ask question later. Okay? Actually, you may also ask question after each question. After I discuss every number, you may ask question. Let's say for number 2, you have some questions. Okay, we can exchange ideas. You can ask your question regarding problem number 2. Then after that, I'll proceed with problem number 3. Okay. So let's say you have question for number 5, so that it will be synchronous. I mean, it will be synchronized. When I discuss problem number 10, you have question for number 10 after I discuss problem number 10. Okay, did you get that? To my Filipino fellow men, so you can break me. You can break. Or while I'm discussing, you can break my discussion, I mean. Or right after I discuss every problem, you may ask question. How? First, you have to raise your hand. Okay? How I really wish that we have 500 participants. So I hope so. So that is our target. What is the next slot in the Zoom? 1,000? 1,000? So that is our target, 1,000. What's the next slot? Okay. Well, our target is 1,000 participants all over the world, no? Who are electrical technology or electrical engineering students. Even electricians, no? Even non-electrical course who are enthusiasts in studying electricity. Okay? So, okay, without further ado, let's start. So, we have direct current circuits part 2 because the part 1 is about the series circuit. Series circuit. This is series circuit. But before that, we have some discussion on electrical principles. No, you may see that in our YouTube channel, in my YouTube channel, Reggie Marinay. So we made a playlist you will see there a playlist entitled Restudy EE. Just in case you were absent on the first day, second day we discussed, you can watch all of these videos. We'll be uploading videos. We'll try our best. Starting today, we'll try our best that every day we'll be uploading some videos. We have so many lecture videos to share with you guys. Okay. So, we have DC parallel circuit. Okay. Maliwanag ako sa inyo ha, mga kababayan ha. Clear tayo, Leo ha. Naririnig ha. Okay. Sige. Isipin nyo lang, nasa classroom tayo. Okay? Isipin nyo lang yon. DC parallel circuit. Okay? I thought this is Mufasa. Si Simba pala to. He is Simba of the Lion King. Okay. So, my favorite movie. Okay? All time. The Lion King. I can relate in the story of this movie. Okay. That's why this is my favorite movie. Okay. So, we have a parallel circuit. Circuit elements are all connected in parallel when the same voltage is common to all of them. Okay? So, in series circuit, the common is the current. The same current flowing to all resistors. Wherein in parallel circuit, the same voltage is being impressed across each resistor. Same voltage is common to all branches, we would say. That is branch or branches, we'll discuss that. Okay, properties of parallel circuit. Okay, so the voltage across each resistance of the parallel combination is the same. So take a look at our electric circuit here. Our voltage source, V sub T, then we have resistors R1, R2, and R3. They are all connected in parallel. Just like in our home. Let's say you have a television, you have a radio, you have a even karaoke. Don't you know that karaoke is invented by Filipinos? Okay? Let's say you have a microwave oven. All the loads in our home, even in buildings, they are all connected in parallel. Okay? They are connected in parallel. Let's say you have 2 or 3 loads. Basically, they are connected in parallel. They have all the same voltage. Let's say you have a 230 volts here on the source. You also have 230 volts, 230 volts, and 230 volts to all the 3 resistances. Okay. R1 is what we call the branch resistance, R2 and R3. These are the branch resistance. Branch, let's say you have 1, 2, 3 branches. There are 3 branches in this electric circuit. They have the same voltages. V total is equal to V1, equal to V2, equal to V3. What about the total current? This is governed by the Kirchhoff's Current Law. Okay, so the total current is this, the current entering at any node. Take a look here. This straight line is just a node or a junction. Okay, another term for node is junction. Okay, we have a junction or node here in the upper portion, and on the lower portion, we have also a node or a junction. A node or junction, it is a point where our total current will divide. This will separate. It depends on the number of branches. In here, the total current will divide into 3. Not necessarily equally divided. It will be dependent on the value of these resistances. Okay? Well, basically, if they have all the same values, let's say 2 ohm, 2 ohm, and 2 ohm, basically, if you have a 9 ampere divided by 3, you will come up with 3 amperes here, 3 amperes, 3 amperes. That will be the case if each branch resistance has the same value. Okay? Let's go over here. So we have here the total current. The total current is equal to I1 plus I2 plus I3. Okay, by Ohm's law, I total is V total then over R total. Okay, so we have V1 over R1 plus V2 over R2 plus V3 over R3. Okay? So, since the voltages are equal, we may cancel out. We may cancel out the voltages. We may cancel out the voltages. Okay? We may cancel all the three. Okay, so I cancel the voltages. See? What will happen now? We have 1 over R total that is simply equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, I will put a parenthesis here. Now, take a look here. Although this is already an equation, then we can simplify further this equation. So we'll come up with R total will be equal to, so we have 1 over R1, 1 over R2, plus 1 over R3, plus 1 over R3. Okay? Okay, so we have our equation. So this is our equation. To get the total resistance. Okay, we have a formula for conductance. Conductance is simply equal to 1 over R. It is the reciprocal of resistance. So we have here the symbol mho or Siemen, MHO or Siemen, or Siemen. Whatever you pronounce it, because I learned I hear English of American, English of Australian, English of British. They have all different they call this accent or pronunciation for every word. Okay, so this is mo or Siemen or Siemen, whatever you call it. Okay. So we have here this equation. Take a look here, guys. Here. So if this is 1 over RT, we may replace this by GT that is equal to, take a look here, 1 over R1, let us represent by G1, plus 1 over R2, G2, plus 1 over R3, G3. Okay? Next meeting will be, we will use this equation. Next meeting. Okay? So this is our GT, which is the reciprocal of resistance. Okay? GT. So let's go over with our PowerPoint. Okay? So we have here the equation. So we have this equation. Again, we have RT. We have RT here. Is equal to 1 over R1 plus 1 over R2 plus 1 over R3 up to 1 over Rn. Okay? Let's say if we have 10 resistors in parallel, that is up to R10. Okay? That is up to R10. So let us discuss the current divider theorem. What is a current divider theorem? This is basically applicable to two branch resistances. Let us get first the resistance for two parallel resistors. I will put here for two parallel resistors. Okay, so for two parallel resistors, take a look here. So we have two parallel resistors. It's simply equal to, based on our formula, so our R total simply equal to 1 over R1 plus 1 over R2. Because there are only two resistors. Okay. By algebra, so we have here 1 over, okay, what is the LCD of R1, R2? It's simply R1 multiplied by R2. So R1 times R2 divided by R1, of course, that will cancel. The R1 will cancel out. Then multiplied by 1. So what will be left is R sub 2. Okay, so put here plus also because of this. Now, R1 times R2 divided by R2, so the R2 will cancel. Then multiplied by 1, so this will be R1. Okay, so we have here the RT, that will be equal to, take a look here, by algebra, I remember my trigonometry teacher, this is extremes, this is what we call the extremes, okay, over the means. This is the means. Okay, outer times outer divided by inner times inner. Okay, so we have 1 times R1, R2, simply R1 times R2. 1 times R2 plus R1, simply, I'll just make it R1 plus R2. Okay, so this is what we call the product over the sum. Product over the sum. That's how to get the resistance for two resistors in parallel. Okay? Now, what about the current divider? Let us derive this equation. Let us derive this equation from the basic principle we discussed. Okay? So, take a look here at our PowerPoint. The total voltage is equal to voltage at R1, that is V sub 1. That's equal to V sub 2. Okay, so we have here, V1 is equal to V total. V1 is equal to V total. What is our V1 equal? What is that equal to? Our V1. Okay, our V1 by Ohm's law, so this is V is equal to IR. IR. If this is 1, this should also be 1. 1 and 1, so V total. So this is I total, then multiplied by R total. Okay? And then, we have here R1, I1, R1, that is equal to I total. Then, we only have two resistors in parallel. Again, what is our equation? The product over the sum. R1 times R2 over R1 plus R2. Got it? Did you get that? So you just have to substitute our equation for RT. Now, take a look here. Of course, this R1 by algebra, divide both sides by R1, that will cancel out. That they are common. Okay, so we can cancel out. I'm sorry that for every meeting, I am pre-assuming that you know already the basics of algebra. Okay? In our studies in this program, we require you to have the basic foundation or basic knowledge about algebra in manipulating the equation. Okay? So, we have, I see a lot of lectures of algebra in the YouTube. It's very nice. You can go over with those lectures also. You can supplement those lectures, okay, before you attend our lecture. Okay, you have to make some review on the foundation of mathematics. Okay, because I'm already pre-assuming that you know some principles in algebra. Okay, so please take a look here again. What will happen in our equation? I1 simply equal to I total multiplied by I total. So we have here R2 over R1 plus R2. So this will be our equation for our I1. Take a look here in our PowerPoint. Is it the same to our equation on the whiteboard? So this is I1, that's equal to IT. So we have R2 over R1 plus R2. Yes, they are just the same. Okay, what about for I2? For I2, we have V sub 2 is equal to V total. Okay, so we have I2, R2. That is equal to I total, R total. Again, we have here our I2, R2. So that is equal to I total multiplied by, again, the product over the sum. Okay? R1 times R2 over R1 plus R2. Okay, since R2 is common to both sides, we can cancel out. Okay? So we have here the equation for our I2 that is equal to IT multiplied by R1 over R1 plus R2. So this will be our equation. Take a look here at our equation. Here, these two equations. Take a look. These two equations. So, if this is 1, this is 2. If this is 2, this is 1. You see? That is reverse. Unlike in our voltage divider, again, what is our equation in our voltage divider? You remember last time? So, we have here V1, that's equal to V total, then what? We have R1 over R1 plus R2. What about for V2? This is our V2. V2 is equal to V total. Then we have R2 over R1 plus R2. You see, in our voltage divider theorem, it says here 1, 1, 2, 2. In voltage divider, that is 1, 1, 2, 2. In current divider, it is 1, 2, 2, 1. You see? You see the difference, guys? Okay, let's continue. I think we're now ready to solve some problem. Okay, let's answer problem number 1. Two resistors, 1.95 ohms. Okay, so we have two resistors, 1.95 ohms and 0.05 ohm are connected in parallel and take the total current of 50 amperes. What is the current through 0.05 ohm resistor? So the question is the current through our 0.05 ohm resistor. Okay, I will draw the circuit first. Let us draw the circuit. So we have two resistors here. We have 1.95 ohms. We have 1.95. And the other resistor is 0.05 ohm. The total current is 50 amperes. So we have 50 amperes. Let's say I total 50 amperes. What is the current through 0.05 ohm resistor? So 0.05 ohm resistor. So let us assume this is our current I1 and this is our current I sub 2. Okay, the current in the 0.05 ohm resistor is I1. Okay, again, our formula for I1, again, what is our formula, guys? So I1, that is our I total, then multiplied by, okay, so that is, if this is 1, this should be 2. Okay, that is reverse, the opposite. If we have here I1, so this is assumed to be our R1, this is our R1, and let's say this is our R2. Okay, so we have our I1 that's equal to the opposite resistance, which is R2, 1.95. I'll just write it down first, the equation, R1 plus R2. So our I1 will be equal to, I total is 50 amperes. So we have here 50 amperes, 50. Then what is our R2? 1.95 over 0.05 plus 1.95. Okay? So let us calculate the value for our I1. What is our I1? Okay, so we have 50 times 1.95 divided by, that will become 2, right? 48, this will become 2. So 48.75. Okay, 48.75 amperes. So that is our current. Okay, that will be letter. What letter is this? Okay, letter D. Then let us solve problem number 2. It is a follow-up question for number 1. What is the current through 1.95 ohms? Okay, so we have the current I2. That will be I2 here. Our I2 will be equal to, again, what is our formula, guys? IT, okay, multiplied by, if this is 2, that must be 1. Okay, so over R1 plus R2. Okay, let us substitute this IT. What is our IT? IT is 50 amperes. Okay, so we have our R1. R1 is 0.05 ohm. Okay, all over 0.05 plus R2, which is 1.95. Okay? So what will be our answer? Let us calculate. So our answer is 1.25. 1.25 amperes. And that would be letter A. What is the letter? What letter is this, guys? This is letter B. Okay? Letter B. Okay, guys, let's continue. Before I solve problem number 3, let's say the question is calculate the total power. What is the total power? There are so many ways to calculate the total power. Okay? Total power is simply, this is our working formula, P total, that's equal to P1 plus P2. That is our formula. Okay, we can have, well, of course, we have this formula, so many formulas. So for power, let us recall, that is VI, that is equal to I squared R, that is equal to V squared over R. So many formulas we can have. Okay, let's say we have here a certain appliance in parallel. So we have P1 that's equal to what formula? Any formula will do. Actually, any formula. I will use this formula, I squared R. I squared R. This is I1 squared R1. Okay, what is our I1? Our I1 simply 48.75. 48.75 squared, then multiplied by R1. What is our R1? What is our R1 equal to? Our R1 is 0.05 ohm. 0.05 ohm. So our P1, our power here in our R1 would be 48.75 x squared, then multiplied by 0.05. That is equal to 118.83 watts. 118.83 watts. What about our P2? P2. Our P2 is I2 squared R2. Okay? So, what is our I2? I2 is 1.25. Okay. Then multiplied by, what is our R2? Our R2 is 1.95. 1.95. So that is equal to 1.25 x squared times 1.95. So that is equal to 3.05. 3.05 watts. Let us get the total. Let us sum up this. What is the total power? This is the P total. Okay? Okay, so we have here we have 118.83 plus 3.05 equals. So we have here 121.88. 121.88 watts. This is our total power. This is our total power. How to check if our answer is right or wrong? By the way, how to check? Just check. Okay? That correct? No, sir. It's not the way of checking. Okay. Well, you can use the other formula here. I just use the second formula, VI, V squared over R. Okay? And what is the easiest? I think this is the easiest to check. To check, there. Okay? So we have our total power, P total, that is equal to B total. So B total times I total. Okay? By the way, what is our I total? Let's get first our I total. That is simply equal to I1 plus I2. We have already the value. Or, actually, that is already given to be 50, right? That is 50 ampere. 50 ampere. And I watched YouTube, he pronounced this as 50 ampere. Ampere. Okay? Okay, so we have here V total. What is P total? That's equal to V total. Oh, by the way, we have no V total here. There's no V total. Okay, by Ohm's law, no problem, no problem. I'll just use this small space here. What is our V total equal? Our V total, what is our, we already have the, what's that? Total current of 50, okay? V total is I total times R total. By the way, we don't have yet our R total. Okay. Our I total simply 50. But what is our R total equal to? Take a look here, guys. I'll go directly with our calculator. Product over the sum. Okay? Okay. Sundan ninyo ako, ha? Mga kawerpa, mga kababayan, sundan nyo ako. Product over the sum. Okay. It's simply 1.95 times 0.05, okay, then divided by the sum of these two. Well, actually, that is just simply 2. The sum of 1.95 and 0.05, simply 2. So, that will be equal to 0.049. Okay, or basically 0.05. 0.05. Okay? We will rounded this off to 2 decimal places, 0.05. Okay. We have a small voltage, 50 times 0.05. Approximately, we have 2.5 volts. 2.5 volts. That is our total voltage. So, we have here V total 2.5. 2.5. Okay, so we have here 2.5 volts multiplied by 50 volts. 50 amperes, sorry. 50 amperes. So we have 2.5 times 50. Our answer is 125. Okay? 125. Of course, we made some rounding off, so there will be some a little difference. 125 watts. Because in here, in getting P1, we have some rounding off here. In getting P2, we also have some rounding off here. So Of course, the total power will become, they call this, just an approximation. It's not exact. Okay? So, anyway, we have, this around 122 watts. This is 125. There's just a difference of 3 watts. There will be no problem. Okay? So, actually, I get here for our, again, what is our R total? That is the product over the sum, 1.95 times 0.05. Okay, then divided by 2. So this is 0.04875. If I will make this as 0.04875 times 50, that will become 2.4375. If I will substitute here the 2.4375, 2.4375 will come up with, is times 50, that's already given, will come up with 121. Okay? This is 121.875. And that is nearer to our total power here. Okay? Nakakuha ba, mga kababayan ko? Did you get that? Okay, kasi nag-rounded off kasi tayo eh, nag-rounding off. Kaya hindi siya talaga sasakto pag nag-round off ka. Okay? So, kasi dito may 0.04875, something like that. No? Ni-round off ko lang kasi to. Okay? Kaya may konti kang difference, 125. But if I will make this, again, as the product over the sum of these resistors, 1.95 times 0.05 divided by 2, that will be 0.04875. If we will make this as 0.04875, okay? You'll come up with this value, and that is very near, okay, to this value. Actually, if you will round up this to 2 decimal places, you will come up with this value, right? Okay, so let us go with our, this is how you calculate the total power, even in our appliances. Okay, just have to sum up all the appliances, no? So that you may size the service entrance conductors or the branch circuit conductor. Okay, you should know the power rating of each equipment. Okay, let's go with problem number 3. So, but before I solve problem number 3, I will discuss to you some principle behind this problem. Actually, this is a licensure exam problem. That is a board exam problem. It says here that a parallel circuit has an infinite number of branches. The value of each branch resistance is 100 ohms. Find the equivalent resistance. What is the equivalent resistance? Remember, we have a parallel circuit, infinite number of branches. The value of each branch resistance is 100 ohms. So all of these are 100, 100, 100, 100 ohms. Find the equivalent resistance. The equivalent or the total resistance. If you have an ohm meter here to measure the equivalent resistances of all these resistors. Remember, we have an infinite number of branches. See? Infinite. That is infinite. Okay? How to do it? Let us discuss first for identical resistors in parallel. Okay. Example, I have two 12-ohm resistors. Two resistors. So I have here 12, we have here 12, and we have 12. Okay, take a look here. Well, that's easy, sir. We studied how to get the total resistance here at these 2 points. That is simply the product over the sum. Okay, so, or, that is 1 over 12. This is plus 1 over 12. Or simply, product over the sum. 12 times 12 over 12 plus 12. So we'll come up with this answer. How much? That is 6. That is the answer. Okay? That is 6. Okay? You see? 6 ohm. If I will add another 12 ohm resistor here, what will be our answer? Just simply 1 over 12 plus 1 over 12 plus 1 over 12. Okay? So put here plus 1 over 12. What will happen, guys? Okay, let us simplify this one. 1 over, okay, so that will be 12. Just copy. Then we have 1 plus 1 plus 1. Okay, so we have 3. Okay, extremes over the means. That will be 1 times 12, 12, 1 times 3, so we have 3. We'll come up with 4 ohms. Okay, 4 ohms. What about, sir? I will add another 1, 12 ohm resistor here. Well, of course, our total will be 1 over 12 plus 1 over 12 plus 1 over 12 plus 1 over 12. Okay? 1 over what? So that will be 12, and this is 1 plus 1 plus 1 plus 1, that will become 4, or just simply 12 over 4. So that will be 3 ohms. What can you say here? What can you say? Sir, as we increase the number of resistance, the total resistance decreases. Okay, what else? Take a look here. If we have only 2 resistors in parallel, we'll come up with 1 over 12 plus 1 over 12. Okay? To simplify this, we'll be having here as our R total, that will just become what? 12 over 2. Just like here, if we have 3 resistors in parallel, 12 over 3. 4 resistors in parallel, 12 over 4. What happened? What can you say about that? The 12 over 2 is 6 ohm. The 12 over 3, 4 ohm. 12 over 4 is 3 ohm. So we may say that the total resistance for identical resistors in parallel simply equal to the branch resistance over the number of branches. That's it. This is our basic principle. This is only applicable to identical resistors in parallel. They have all the same ohmic values. Okay? Ohmic value. Therefore, if I will solve this problem number 3, What is our total resistance? Simply equal to what? What is the branch resistance? 100. What is the total number of branches? We have an infinite, so many branches, infinity. Okay? That's a never ending, means infinity. That's why I believe with forever. Okay? See? I saw a ring that has infinite shape. That is the ring of Don Sulweta, our movie actress. Okay? With Richard Gomez. No? So, ano bang palabas yun? Walang hanggan. Walang hanggan. Okay? This is infinite. Remember, if we are talking of infinite, walang hanggan or never ending. Okay? Never ending. Infinity. What is any number divided by infinity? Any number divided by infinity, that is zero. 0 ohm. What can you say if you have a tester? It deflects in 0. I have my tester here. Okay, let us demonstrate. See? I will teach you how to use this. Maybe I'll schedule that. How to properly use this multi-tester. This is a Sanwa. This is original, huh? Okay. I bought this for around more than 2,000 pesos. One. This is Sanwa. Original. But you can buy around 200 pesos in hardware. Okay, in our place. Okay, so you see, there is 0 ohm here. There is infinity. Infinity means open circuit. Then, if we are to short the two terminals, that will deflect to 0. That will deflect to 0 here on the rightmost. That will deflect to 0. If that will deflect to 0, meaning the circuit is a short circuit. That is the most dangerous circuit. Okay? Short circuit that causes electrical fire in our building. That is shorted or short circuit. Short circuit. Okay? Short circuit. I'll promise to you, I will conduct a lecture on short circuit when we go to power system 2. And that will be next year. Okay? So, maybe a year or 2 from now. Okay? So, because we will do this one in a very detailed manner. Way of discussion is very detailed. This is a college setup. Okay? The standard third-year college setup in electrical engineering course. Okay. So we have here a short circuit, 0 ohm. Let's take a look. What letter is our final answer? For letter A, we have 100 ohm. Just the same value? No. It's not voltage, it's resistance. Okay? Infinity? No. It's not infinite. Undefined? No. That is shorted. That is shorted. By the way, what do you mean by undefined? Undefined. What do you mean by undefined? So, undefined means undefined I'll give you an example of undefined equation. Let's say you have 2 over 0. We have 3 over 0. 5 over 0. Any number over 0 is undefined. Then there is what we call indeterminate. Indeterminate. Or undetermined. Undetermined. What do you mean by this? I remember in differential calculus, we have a class then that equation that's about the L'Hopital's rule, it comes up to have a 0 over 0. My student would answer, what is 0 over 0, class? Sir, that's 1 because this just canceled. Oh, really? That's wrong. Okay? That's wrong. To our Zoom participant, in our Zoom class, please open your camera because that is a requirement before we give you the certificate. So that is part of the requirement. Please open your camera. Everyone, please. We'll be waiting for you guys. Please open your camera. If you will not open your camera, I'm sorry that we cannot provide you the certificate at the end of the course. Okay, let's continue. Sir, 0 over 0, that's simply 1. No, that is wrong. That's wrong. Okay? You cannot divide this. Let us try in our calculator. That is 0 divided by 0. What will be the answer? The answer is math error. In our calculator, that will be math error. See? That is math error. That cannot be solved by our calculator. There's another one. Infinity. We come up with this equation in differential calculus, I remember. What is the value? There, cancel. That's 1. That is another wrong. We call this as indeterminate or undetermined. Indeterminate. Okay? These are indeterminate form. Cannot determine this. I remember my student, he asked me, sir, is there any number greater than infinity? Is there such a thing? What's that number? Sir, infinity plus 1. Wow, that's great. Are you joking? So, well, if you have infinity plus 1, you'll come up with infinity plus 2 plus 3. You'll never end. There's no number greater than infinity. Okay? Although there was a number discovered, who discovered that? They call this as Google. Google, that is 1 followed by 100 zeros. There are 100 zeros. You see, a handful of sand in the beach. That is Google or Google, how you pronounce it. Maybe the Google company got its name here. Okay? Google ka ba? Kasi nasa iyo na lahat eh. See? Wala na, hindi na patok yung joke na yun. Wala na. Okay? 1 followed by 100 zero. A handful of sand is Google. It's not million, it's not billion, it's not trillion. It's Google or Google. You want a proof? You count. You count. Okay? So, let us continue our discussion. Let's go over with problem number 4. Okay, problem number 4, it says, 3 120 ohm resistors are to be connected in parallel connection. Calculate the total power for an impressed EMF of 120 volts. So we have number 4 problem. Okay, so we have here 3 120 ohm resistors. So we have a resistors here. Okay, so we have here, I will draw first our Okay. So we have three 120 ohm resistors in parallel. Calculate the total power for an impressed EMF of 120 volts. Okay, so let us have the working formula. Calculate the total power. The total power, I will make use of the total voltage squared over the total resistance. What is our total resistance? Okay? Let us make use of our formula for identical resistors in parallel. What is this? We have 120 ohms. That is the branch resistance over the number of branches. How many branches do we have? 1, 2, and 3. 120 over 3, so we'll come up with 40 ohms. So this is easy. So P total, that will be equal to V total. Our V total is 120 volts, okay, squared, then over 40 ohms. So what will be our answer? 120. X squared, then divided by 40, will come up with 360 watts. So our answer would be letter D. Okay? Very easy. Okay? That's very easy. Next, number 5 problem. Okay, problem number 5. A resistor R is connected across a 220 volt supply. A voltmeter of resistance of 10,000 ohms is connected between the center of the resistor and one side of the supply. It reads 100 volts. Find the value of R. Okay. Let us go here one by one. There is a resistor R connected across 220 volt supply. Okay, so let's say we have here a resistor that is connected to negative, positive. There you are. We have a resistor R here. Then we have a voltmeter. It says in our problem that there is a voltmeter of resistance 10,000 ohms connected between the center. So let's say this is the center of this resistor. Let's say this is our resistor R connected between the center of the resistor and one side of the supply. Let's say we have here a voltmeter. Okay, there you are. So we'll come up with this figure. Okay, we have a voltmeter tapped from the center to one side of the supply, which is the negative side here in our figure. Okay, so one side of the supply. It reads 100 volts. Find the value of the resistance. Okay, I will redraw this circuit, guys. I will make this into two resistance. Okay, 1, 2. Negative, positive. Okay, and then I will put here, if this is R, remember that our voltmeter is being tapped on the center. Let's say this is the center of the resistor. So there is a voltmeter here. Okay, and on this side, this is our voltmeter. Okay, that is our voltmeter. It reads 100 volts. Let's put here 100 volts. Our supply voltage is 220 volts. 220 volts. Find the value of R. This will become R over 2, R over 2. Please listen carefully. In a class, let's say I have around 40 students. I have 40 students. I will give this question as their examination. There will just be around 5 students or less than 10 students will get this correctly. Okay? They find it hard. Majority. Less than 10 students will get this correctly. Okay? Remember, in the licensure exam, we are mostly given a worded problem like this. Most of the questions are not in drawing or in picture. Okay? You have to think of the picture while you are reading the problem. This worded problem. Okay? This is already part of the solution. This is already part of the solution. Discarding nyo na yon. No? Kaya siya nagpahirap. Pag nagbigay ako nito sa estudyante, sa 40 student, maswerte na 10 makakuha. Minsan nga, may isang section, 2 lang. Okay? Why is it hard? Very short solution, but quite a hard analysis. Okay? So, take a look here. Take a look here. So, we have here a 220 volts. Of course, this will deliver a total current, right? Take note that the voltmeter is always connected in parallel. We have a voltmeter here, then we have a resistance R over 2 here. Again, why is this R over 2? Because it says in the problem that the voltmeter is tapped on the center of the resistor and one side of the supply. I will call this as total current. And I will call this current as I1, the current in the voltmeter, and the current at R2 here will be I1, this will be I2. Okay? So, let's make use of the Kirchhoff Current Law. The current entering at any node is equal to the current leaving. As simple as that. Just like a water pipe. Water will flow in this pipe. Okay? Then there is we have here, we have a pipe here and we have another pipe, no, that will divide into two. The flow of water. Okay? So, our I total, take a look here, guys. Our I total simply equal to I1 plus I2. Okay, by Ohm's law, take a look, guys, here. Remember that the voltmeter reading is already 100 volts. Therefore, this is basically a series circuit. You see, in our powerhouse chap-chap law, did you remember that? The voltage here plus voltage here is equal to the voltage here. See? So, if this is already 100 volts, for us to come up to 20 volts, at 220 volts, what is the value of this? What will be the value of this? It should be what? 220 minus 100, right? What is 220 minus 100? That is 120. That's how they pronounce this in New York, okay? In US, 120, and 120. What's the time now? That's 11:20, okay? So we have here 120 volts on this point and on this point at the node, okay? So by virtue of Ohm's law, what is the total voltage here? This is, remember, this is our I total. That is the current flowing to our R over 2 here. By Ohm's law, this is 120 over resistance, because current is voltage over resistance. Voltage over resistance. What is the resistance here? simply we have R over 2. Okay, what about for I1? For I1, that is the current flowing in our voltmeter. We have 100 volts, then divided by the resistance of the voltmeter is 10,000 ohms. Put here 10,000. So, that is plus, because of plus here. What is our I2 now? Remember, this is in parallel circuit. The voltmeter, it has resistance, and we have R over 2. So, they are connected in parallel. So, therefore, we can make use of this voltage. For parallel, they have the same voltage. So, we have 100, then over what? For our I2, R over 2 also. The resistance here, R over 2. There is only one unknown. This is very easy in our calculator. Just shift solve, okay, in our calculator. But if you don't have this type of calculator, so you have to manipulate this one. That's very long. We will manipulate this manually, okay? So let's just make use of our calculator so that we can discuss so many problems. Okay, so let us have now our calculator. So 120, then R, you replace R by X, variable X. Okay, so we have over 2. Okay, let's just wait for the, there you are. So the answer is 4,000. Our R is 4,000 ohms. This is a past board exam problem. Okay? I think it belongs to moderate to difficult category. Okay? So, of course, if this will be given again in your licensure exam, di na mahirap yon, madali na yon. This is already easy. This problem will give again in the board examination. So we have 4,000 ohms. Let's go with problem number 6. This is about battery. We already discussed the basics of battery last time. Okay, are there any question, guys? Will you raise your hand who has question? Anybody? Oh, sino may tanong sa inyo? Mga kababayan. No question? Okay, no question. Okay, I'll continue. Nobody is raising their hand. No question? What about Miss May? Caris, any question there? Okay, no question. Let's go over with problem number 6. 10 cells, each of EMF 1.5 volts, and internal resistance of 0.2 ohm are joined in parallel and connected to an external circuit of resistance 3 ohms. What current will flow? Okay, let's have number 6 problem. 10 cells each of EMF 1.5. Okay? They are joined in parallel. So there are 10 cells in parallel, basically. So let's say we have internal EMF, internal resistance of each cell. Okay. Okay, so these are the 10 cells. So I will not draw any more 10 cells here. So this is automatically cell number 1, number 2. This is the 10 cell. Okay. 10 cells, each of EMF 1.5 volts. Internal resistance, 0.2 ohm. And connected to an external circuit of resistance 3 ohms. So there is an external circuit here. Let's say we have here 3 ohm resistance. What current will flow? Basically, that is on the 3 ohm resistance. What current will flow? There you are. There is an equivalent circuit. Let's have first the equivalent circuit. This will be our equivalent circuit, guys. We have the total. This is our ET. Then we have our RT. Then this is our load resistor, which is the 3 ohm resistor. What is our ET, by the way? Take a look here. So we have 10 cells, each of 1.5 volts. Remember, we have 1.5 volts. That is in parallel. Remember that E total will be equal to E1 equal to E2 up to equal to E10, which is simply equal to 1.5 volts. Okay? What about our internal resistance, RT? Okay, we already studied this before. How? They are connected in parallel. So, let us assume first that our voltage here is shorted. That is short circuit. What will be left is just the resistances. We have 0.2 ohm per cell. 0.2 ohm per cell, then we just have to divide it by 10 because there are 10 cells. So therefore, this will become 0.02, right? 0.02 ohm. So we are asked to find the current flowing in the load. So that is our current I. That is the question. Our current I simply equal to, what is our basic formula? This is just a basic Ohm's law. What is current I? That is the total voltage, which is our ET, over total resistance. What is the total resistance? The series combination of big R to the small RT. So therefore, now we have our I, that is actually our total current. What is our ET equal to? 1.5. Big R, 3, plus 0.02. So let us calculate our load current. What is our load current here? We have 1.5, then divided by 3.02. 3.02. The answer is 0.497. 0.497 ampere. Okay, so the answer would be letter. Okay, what is our letter? Letter C. Very easy. Okay, that's very easy. Okay, so let's go now to problem number 7. 6. Okay, number 7. So we have here a resistor of 0.525 ohm is connected to the terminals of the battery, consisting of 4 cells, each of EMF 1.46 volts, joined in parallel. The current is found to be 0.8 ampere. Find the internal resistance of each cell. So the question is the internal resistance of each cell. Okay, so we have for number 7, a resistor of 0.525 ohm connected to terminals of battery, okay, consisting of 4 cells joined in parallel. So we have 4 cells. Okay, 4 cells each of EMF. So we are given our E here. Okay, they are all identical. I'll just represent each EMF as E. So we have here simply as R. Okay. Okay, so we have here 4 cells. So we have a load resistor here of 0.525 ohm. Okay, of course, we have a total current here or load current I. That is already given, 0.8 ampere. Find the internal resistance of each cell. So this is just the question. The internal resistance of each cell. Let us go over with our E first. Again, just like what we did in the previous problem, what is our E equal to? The internal EMF of each cell. Actually, they are just all equal because they are connected in parallel. So that is 1.46 volts. Okay, then we have here internal resistance. Internal resistance. Anyway, that's the question. The internal resistance. Remember that our E here is simply our E total. E total. What about our R total? Total internal resistance. As we see here in the previous problem, number 6, this is 0.2, that is the resistance per cell. And 10 is the number of cells, or particularly, that is the number of branches. Just like what we did before in the infinite, in the problem that has infinity. So we have here, what? Simply equal to the branch resistance. The branch resistance is represented by small r over the number of branches. What is the number of branches? 1, 2, 3, 4. There you are. Okay? So, let us have our equation for the current. Just like before, okay? We have the equation for current. I simply equal to E total. I will not write anymore the equivalent circuit. The equivalent circuit is just like found in number 6. See? We have E total in series with RT, and then the RT is in series with the load resistance R. Okay, let's go over with our equation. I is equal to E total over big R plus RT. Now, we have here our values. Substitute. Let us substitute these values. E total is 1.46. What is our big R? 0.5. That is 0.525 plus RT. What is our RT? R over 4. R over 4. By the way, we already have the value for our current, 0.8. Okay? Only one unknown, shift solve in our calculator. Let us shift solve. Let us input this in our calcu. Okay, let's just wait for the answer. Okay, my answer here is 5.2. 5.2. The answer would be letter C. Okay? Nakakuha po ba yon? Okay? Tandaan nyo, pagka parallel ha, resistor, yung branch resistance, divide mo lang kung ilan yung branches niya. No? For this case, 4 yung branches niya, di ba? Okay, so sagot natin, 5.2 ohm. So this is our final answer, 5.2 ohm. Okay, letter C. Let's solve next problem, number 8. We are given 20 cells. We are given 20 cells, each of EMF 1.5 volts. Internal resistance 0.2 ohm are arranged 10. Remember, they are 10 in series per row. So 2 rows. 2 rows meaning you have 2 branches now. You have 2 branches. Okay, let us draw first. We have 2 branches, 20 cells all in all. Per branch, we have 10 cells per branch. Say this is the first cell with resistance, second, and then basically this is the 10th cell because there are 20 cells in the problem. 20 cells, then we have 2 rows, meaning how many cells do we have here? If this is our E1, this is our E10. E1, E2, up to E10. So that the first row, let's say, is 10, and this is 10 also. There are 10 cells per row or per branch, basically. So, we have here a load resistance, R. Here. We have a load resistance. So, we have 20 cells, each of 1.5 volts. Let us put here 1.5 volts and internal resistance 0.2 ohm. So 0.2 ohm are arranged in 10, meaning there are 10 cells in series per row. So 2 rows in parallel. What current will this give through an external resistor of 1 ohm? So our resistor here is simply 1 ohm. So the question here is our current. What is our current here? Let us get the EMF per row, the total EMF per row here. Because the EMF here on the first row is equal to the EMF on the second row. Got it? Because they're just simply connected in parallel. They're just in parallel. But there are 10 cells here in series. So therefore, our E per row, shall we say, E per row. Shall we say this is our ER, E per row. So that will be equal to 10 times E. 10 times E. Or just simply 10 times, what is our E? 1.5. So our E per row will be 15 volts. 15 volts. If we have 15 volts here, we also have 15 volts here. Okay? Because they are just in parallel. Okay? The E per row, you may conclude that it is equal to the total EMF. Isn't it? That is the total EMF. Total EMF, ET. I will not draw anymore. Just like number 6. Take a look here. We have ET, then in series with RT. Then we have R. Just remember that very basic circuit. It's a very basic. Okay. So, the question is the current. Again, by the way, let us get our internal resistance per row. The internal resistance per row is 10 times the internal resistance of itself, 0.2. So, you will come up with 2 ohm. That is the resistance per 1 row here or per branch. That is the equivalent resistance. But, if we are to get our total resistance, total internal resistance, I mean, what is our total internal resistance? How to get? Please listen carefully, everybody in the world. Okay, hello world. Okay, hello. Okay, so, pakinig pong mabuti, mga kababayan. So, we have RT. Now, this is the R per row. This is R. RR, I mean, the resistance per row. This is RR. So, we have 2. Therefore, if we have 2 here, that is the branch resistance over the number of branches. We only have 2 branches. 2 over 2, simply 1 ohm. Got it? Then, think of the formula for the current. Again, what is our formula for the current? That is our E total over the load resistance plus the RT. That is the total current. That is the basic battery equation. So, we have here I that is equal to ET. What is our ET? 1 point, by the way, it is 15 volts. Okay? Then we have what now? R is 1 plus 1. So our I, this will become 2, 7.5 amperes. 7.5 amperes. That is our answer. Okay? The answer would be letter D. Okay? Very hard. Very hard. Okay? Is this very hard problem? No, that's only very easy. Okay? You just have to know the basic principle. Okay? Always stick to the basic. Always remember that. No matter how complex the problem is, always go back to basic. Always know your fundamentals. Okay? I heard in the radio, in the Wish FM radio, our #1 radio station now, it says there is a simple solution to your most complex problem. And that is prayer. Prayer is a simple solution to your complex complex number. Your complex problem. Again. Edit mo yun, ha? Prayer is a simple solution to your most complex problem. Okay? So, of course, everybody in the world is experiencing this complex problem, COVID. There's only one solution for that. Not the vaccine, that is just a tool, but the prayer. That's the most powerful tool. Okay? So we have, let us pray that they will discover the vaccine now. Okay? Let us pray for that. Okay, so letter D. We are only on number 9. There are 20 problems to be solved. It's already 11:45. Okay, let's continue. Hello! Mga kawerpa, nakikinig pa ba kayo dyan? Pakita mo naman na para makita sila ng mga tao sa buong mundo. No? Okay? We are doing this. This is a unique way of online class. There's no one you can see here. We dare you in the Zoom, in the YouTube. You can see this type of lecture. Although we are not perfect, of course not. But there's no style. What do I mean style? This is a unique style. There is a student, we call that as a Zoom class. This is a virtual classroom. Okay? You may ask question, just like what I've said before. You can interrupt me. You may raise your hand so that we will unmute you. You can ask question. So far, do you have question, guys? Oh. Are you getting me? Can you follow the flow of our lesson for today? Can you follow? Can you follow? Yes or no? Thumbs up nga kung naintindihan naman. Nakukuha naman? Oo. Meron din nagtataas, di nakukuha. Okay. Sige. Kung may tanong kayo, magtanong na kayo, ha? Oh, may tanong ba kayo? Tanong. Leo, do you have question? Do you have question? Yan. Mag-unmute si Leo. Sige, unmute mo siya. O, pakita mo siya sa YouTube para makita siya buong mundo. Malay mo, mapapanood to ng mga Amerikano, mga Briton. Ha? O. You have to ask in English. Okay, ha? Okay.
Now, sir, just
yes, what's your question, Leo? Please speak louder, please. Medyo lakasan mo dyan. Lakasan mo dyan. Okay, Leo, speak louder. Speak in English.
The complex equation, sir, I need to study because calculator techniques is a shortcut. So maybe next time I can ask this question how to manipulate the equation.
Using the calculator, you mean?
Using a calculator,
yes.
It's quite easy, but the conventional calculation I need to.
The conventional way, you have to go to algebra. because we
Yeah.
cannot solve this anymore in an algebraic way, I should say.
Yes, sir.
Just like my premise before, I've said before that you have to review your algebra, okay? For you
Okay.
to because if we are to uh, go over again with our solution and solve this algebraically, maybe we can just finish around 2 to 3 questions only.
Yes,
And
yes, I
I'm planning
understand.
to solve 20 items for today. So we are not on a halfway. Okay? Maybe we are just
Okay.
around 40%. There is still 60% and it's already 12 noon. Our target is up to 12:30 only. So meaning I only have around 45 minutes to finish the 11 problems. So I cannot do that. Sa Enverga ka ba? ETF ka ba? ETF ka?
Yes, sir. I'm ETF graduate last
Oo.
year.
Hirap yan yung mga ETF. Pag kasi yung math, wala kayong math at saka yung ESAS. Tama ba? Hindi
Yes,
masyado
sir.
yung math ESAS sa inyo na
Yes, sir. I'm
Kaya dapat balikan ninyo yung mathematics. Anyway, yung math naman nitong DC, pang ano lang naman to, first year college, no? O high school math ito eh. I can assure you, kahit high school, basta balikan mo lang yung high school algebra mo, you may understand this. You go back to your high school algebra, I suggest you read your notes or any book. Even a high school algebra will do. No?
yes,
Even
sir.
a high school algebra. You will understand it. Okay? You want to manipulate it in a detailed way, the equation. So you have to
Yes,
learn
sir.
that. You have to just like what I've said, there are so many lectures in YouTube. There are good lecturers in mathematics in YouTube. Actually, we have also plan of doing it. Are you already master electrician, Leo? Not yet.
Yes, sir. Yes, sir.
You are already RME?
Yes, I was.
RME
I'm.
license ka na?
Yes, sir.
Okay. Sige, okay. It's quite hard for a shortcut course because they studied only for 1 year. Is that correct, Leo? Please correct me. You studied approximately 1 year only of Bachelor of Science in Electrical Engineering. Is that correct? That is an ETIA program, right? Hindi ko marinig si Leo. Hello, Leo, hindi kita marinig.
Hello, sir.
Oo, gaano katagal yung pag-aaral ninyo ng BSEE?
It was 1 year compressed course.
1 year, yes, it's quite hard. It's really very hard.
Yes.
1 year, only 1 year. That is a shortcut program here in the Philippines that we have what we call the ETF. What do you mean by ETF? Expanded, I forgot, tertiary education. What do you mean by ETF, Leo? Expanded
Tertiary education.
tertiary education.
Equivalency program.
Equivalency program.
Equivalency appreciation program. Sige nga, sir, ano ibig sabihin ng ETF program? Will you educate us, Sir Garcia? What do you mean by ETF program of our Commission on Higher Education? What is that?
Expanded tertiary education equivalency program.
Okay. Okay,
1 year.
thank you, sir.
1 year of study.
So that, if I'm not mistaken, that is given to at least 25 years old. These are already experienced, let's say, technician or electrician. They want to become an electrical engineer. There is a shortcut program for only 1 year. Is that correct, Sir Garcia? Tama ba yon? Yon. Please, thumbs up. Okay, he agrees with that. So it's really hard for you. That's why your dean, I remember, we have some students in our class. Your dean is suggesting to the graduates that you review for 2 times. Enroll in the review center for 2 times. They are suggesting that. Well, of course, that's costly. That is why we have this program to help you guys. That is why we have this program. We also have some math lecture. We have some lecture please go to my YouTube channel. There are some playlists for REE review. You may use it. But of course, we cannot download all our videos in the review. Wala na mag-i-enroll pag ginawa namin yun. No? So, meron kami mga patikim na mga lectures. Okay? And I do believe that we are the most generous review center, giving this knowledge for free to everyone, to everybody. Not only in the Philippines, but to the world because of this YouTube. Right? A big help. Malaking tulong itong YouTube na to. Gusto ko sana may mga Amerikano dyan eh. Afrikano, Indian, Pakistani. Gusto ko may iba-ibang lahi. Gusto ko matulungan din natin sila. Yung mga estudyante ha, I'm referring to the student. Kasi hindi naman naturuan na maayos yung iba doon. No? Yan kasi yung paniniwala ko eh. No? Hindi naman naturuan na maayos yung iba. No? Kasi may mga teacher, sobrang bilis magturo. They teach too fast. Their student will not understand the lecture. There is like that. There are some teachers are like that. It's very hard to catch up for the student. If you are teaching too fast, you think that your student, especially if the teacher is a board top-notcher or is a very intelligent teacher, I mean, he got a first placer in the licensure exam, then he just thinking his student is his student will understand his lecture. It's very hard. Teaching is another talent. And we will do that for you, guys. Of course, sa isang pasada, no? In one round, you cannot understand this that easy. Okay? I suggest that you view it again in the YouTube. After our live stream, okay? Take a break for 1 hour break, then you view it again. And then you have some post, and just to copy the solution, the questions, you can post it, right? Post it. Okay. Then you write down the solution. You can then you can understand easily. Okay. And for Leo, for Sir Garcia, you have to extra effort on your mathematics. We have plan of giving mathematics tutorial. But that may be too long. Di pa ngayon. No? So you better consult your even high school math, I believe. Kahit sapat yun eh. Balikan nyo lang yung mga kahit bili kayo ng high school math lang ng mga algebra book. I saw algebra book of high school. Talagang medyo advanced na rin sila eh. Parang pang college na rin yung kanilang level of difficulty sa mathematics. No? Lalo yung mga senior high natin. Kasi alam ko, nakikita ko sa mga anak ko yun eh. No? Nakikita ko eh. Mga libro nila, medyo high level na rin yung mathematics. High school, may calculus na eh. Even high school student, they do have already a calculus subject. Okay, let us continue our discussion. We are only on number 9. I suggest you, Leo and Sir Garcia, I suggest you view this again. Panoorin nyo ulit ito sa YouTube. Pag isang pasada, tandaan nyo, hindi nyo kagad magiget yan. And the most important thing, wala pong kwenta yan, kahit na 100 times ka. This is nothing if you just view it even for 100 times. You can be like me or exceed me. You can be better than me if you got a good skill set. You have to develop your skill. A skill must be developed. This is what we call proximity. I'm teaching you. I'm giving you proximity. There are 3 requirements to develop your skill. What are these skills? I'll show you this one. This is what we call a pi. Pi. P-I-E. P means proximity. You have to develop proximity. What do you mean by that? What we are doing is proximity. I am teaching you. There should be a mentor teaching you. Of course, you have to teach yourself also. After the class, teach yourself. Okay? There are books available, many books, and a big factor is the YouTube. Wala ito nung araw, napakalaking bagay nitong YouTube na to. Ito, dati may bayad sa amin itong ginagawa namin. Ngayon, libre na lang. Nakita ninyo? Against nga yung iba sa akin ng mga engineer. Kagabi lang, may kausap ako. Against siya sa ginagawa namin. He is against. Why? Because he said that this is an intellectual property. That you should not doing that. Intellectual property yan ng inyong review center. Bakit nililibre mo lang? Binobroadcast mo ng libre. Isip-isip ko lang at the back of my head. Wala kang pake. What's that in English? Wala kang pakialam. No? Okay? You're not concerned here. No? This is our decision and my business partner's decision. So, sabi niya, sir, bakit inaano nyo yan? Kasi intellectual property yan. Kaya hindi nga to ginagawa ng ibang review center. No? The other review and training center are not doing this. Because, sir, baka hindi na mag-enroll sa inyong mga bata. Baka maubusan kayo niyan. Baka maubusan. Eh, hindi kami mauubusan. Tiniti ako sa inyo. So be it. Matulungan lang namin yung walang pera. Nakukuha nyo? Kung yun ang thinking nyo. Pero, kalkulado namin yan. Hindi naman namin siyempre ibibigay lahat. Business side, we cannot give all, of course. But, we are generous enough to give this thing. That's why there's no review center doing this. There. There's no review center in the Philippines doing this. Even in the world, there's no setup like this. That's why we are proud to ourselves. And we are proud that we have this faith that helping people. Okay? We never get tired of doing good works. We are doing it in a Christian way. Okay? So, we are the most generous review center that you will meet. Okay? How to develop your skill set. Number one is proximity. You need the help of your mentor, your teacher. Next, what is this? Immersion. You should immerse yourself. I hope I have a right spelling. Immersion. You have to immerse yourself. Meaning, just like on the job training, right? They called it sometimes as immersion. Okay? So you have to submerge yourself. Babad, ika nga, babad mo yung sarili mo. There is immersion. Yung ginagawa nyo, pag-attend kayo ng attend, immersion yan. And then, what is I? E, experience. You have to solve. If we mean experience, you have to apply. You have to apply what you learn. Hindi nyo matututunan to pag hindi rin kayo nag-solve. You have to apply this at home. You solve also for yourself. No? That's how you develop your skill. Remember that. Remember that. Okay? I saw in the YouTube, you have to motivate you. Okay? He said that motivational video doesn't work. I agree with him. You need a skill set. You need a skill. It's you must motivate you. Actually, that term, I disagree with that term. It's you will motivate you. Of course, we have to believe with ourselves, but with God's help, even there's no people motivating you, but God will motivate you. And our Lord Jesus Christ. Amen? Okay. So let's continue, guys. I don't agree with that. It's you motivate you. No, you can motivate yourself. But if you have fear of the Lord, that's wisdom. You can easily motivate yourself. Okay. So remember this triangle. Remember the pi, like pizza pie. Okay? Again, what is pi? P, what is P? Proximity. What is I? Immersion. What is E? Experience. You need these three to develop your skill. You cannot be Bruce Lee. You cannot be LeBron James. I want to become LeBron James. I want to become Michael Jordan. But you don't practice. You don't play basketball that much. How? You want to become Michael Jordan, but look what Kobe Bryant did. Right? He copied Michael Jordan. And he became famous. Okay? Okay, let us continue. It's already 12. Okay, let's continue. I hope I can finish this. Let's go to number 9. Tama ba? Number 9 pa lang tayo? Bihira, number 9 pa lang. Okay, sige. Kaya sabi ko sa inyo, mahabang pag-aaral to ng electrical engineering. So we have 32 cells, each of having internal resistance of 4 ohms. Are arranged 8 in series per row. They are arranged 8 in series per row. So we have 32 cells. There will be 4 rows, meaning there will be 4 branches. 4 branches. Per branch, how many cells? Remember, we have 32 cells. 32 divided by 4. That is 8. Meaning, there are 8 cells. I'll just make it like this one. This is the first cell, and this is the 8th cell. There are 8 cells. And how many rows? There are 4 rows. Okay, let us sketch this one. Just like what I've said before, I remember. Experience is the best teacher. I don't believe. Sorry to say this. I don't believe. Experience is the best teacher. Why I do not believe? Experience is the best teacher. That is incomplete. As an engineer, you should know the theories, principles, or standard. Experience plus the theories, principles. There should be 2. If you want to become an engineer, even a master electrician, experience is good, but you have to combine it with principles, theories found in the book, in the internet, in the documents, in the standard, IEEE standard, IEC standard, Philippine Electrical Code, National Electrical Code. That's the best. Okay? You need to learn also the principles. The principles plus experience is the best. Experience only, I disagree. You have to complement it or supplement it with the theories and principles. That's the best. Okay? Experience alone, for me, that's not the best teacher. Please do not misinterpret me. It's just that that is incomplete. You just have to add theories, principles, standards. No one. Ikaw na pinakamagaling pag ganun. You are a combination of the theory and actual. Okay? So, 32 cells. There will be 8 cells in series per row, having an internal resistance of 4 ohms. So, there are 4 ohms each. Each cell has 4 ohms. Let's say R1 here, 4 ohms. 4 rows in parallel, they send a current of 1 ampere. So there is a current of 1 ampere through an external resistor of 8 ohms. One ampere. Okay? They send a current of 1 ampere through an external resistor of 8 ohms. Find the EMF of each cell. So this is the question. The question is the EMF of each cell. That is the question. How many cells do we have? 32 cells. So per row, we have 8. 8 cells, 8, 8, and 8. Again, take a look at our formula here. This will be our working formula, guys. Take a look here at our formula. The question is our E here. So this is our question. By the way, it's not actually E total. That is our E per cell. What is our E per cell? E per cell. Our E, okay, I'll go here. Our E per cell well, our E per cell is simply our what? Take a look here. Our E per row divided by 8. But what is our E per row? E kada isang row. Okay? Remember, that will become our 8E, which is equal to what? E total. The E per row is this. Of course, they are in parallel. They have the same. For the first, second, third, and fourth branch or row. That is your E total because they are in parallel. Okay? Remember that. That is our E total. Okay? So, E total natin yun. So, ito hinahanap. May kuryente na tayo. We have current. We have load resistance. Then, what about our RT? Let's go here. What is RT? Remember, there is a resistance per row. That is a resistance per row that is divided by 4. Because there are 4 branches. By the way, what is the resistance per row? What is our resistance per row? Here. We have 4 times 8. So, 4 ohm times 8. So, we come up with 32. That is the resistance per row. Resistance per row. The total resistance, again, that is the resistance per row divided by 4 because there are 4 branches. 32 divided by 4. So, we'll come up with 8 ohm. Okay? So, we are now ready. With this formula again, I is equal to ET over big R plus RT. That is our working formula. What is our total current? Given 1 ampere. That is equal to ET. What is our E total? E total, okay, let's go back again here. Our E total is 8E. 8E. Over big R, 8. Plus small RT, also 8. Chip solve. Okay, this is by algebra, Leo. This is easy also. Okay, so can do this one. 8 plus 8, so we have here 16, right? This is 16. 8 plus 8, that will become 16. 16 cross multiply, 16 times 1, so we have here 16. That is equal to 8E. So therefore, let's continue here. So that will be 16 over 8. That our E now will be equal to 2 volts. That is the answer. Take a look here. There you are. Do not include the Z. Okay? That is our answer. Okay, let's continue. 10 to 16 problem. Sige, tapusin na natin to. Up to 20 items. Okay, let us finish this up to 20 items. Oh, by the way, are there any question? Anybody? Because it becomes more complex as we go along. As we progresses to our topic, okay, it becomes more complicated. So I want you to ask questions. It's already around 12:15 in our time here. Any question? Any question? I saw number 10 to 16. That is a new topic. I have to discuss a lot of principles before I solve this problem. I think I don't have the luxury of time. So maybe I will just continue this one on Monday. Actually, starting this Monday, August 31, it will be MWF na. It's already MWF. The TTH will be our pre-webinar, the schedule of our pre-webinar. That is TTH, Tuesday and Thursday, pre-webinar. That will be a Taglish. Or let's see, on Tuesday, well, that is Taglish. On Thursday, the pre-webinar, I want to make it in English also. English and Filipino. What we are doing right now is English-Filipino. Kasi ako naniniwala, no? Kasi elementary pa lang tayo, English subject na eh. No? Naintindihan nyo ito. No? Any question? Please show to our YouTube viewers that we have a Zoom class here. We have a virtual classroom. Any question? Any question? I think I don't have the luxury of time, guys. I have to continue this on Monday. This is quite a long problem to solve. There are so many principles to be discussed. I have to discuss many things here for number 10 to 20. Any question, by the way? Oh, is Aristelo? Do you have question? Don't have question? Oh, magtanong na kayo. Sir Garcia, do you have any question? Do you have any question? Sir Garcia? Naintindihan ba, Sir, Sir Silva, Aristelo? Nakukuha po ba? Nakakasunod po kayo sa lecture? Okay, si Sir Leo. Oh, Sir Leo, baka may tanong ka. Wala, clear naman. Mark Anthony. May nagtataas na kamay. Sino? Siya may tanong. Sige, sige, highlight mo si ano. Sir, mag-English ka ha. English dapat ha. Nakaano tayo sa Facebook. Nakikita tayo. Buong mundo. Okay. Sige. Okay, Sir Leo. What is your question?
Sir, Aris.
Nakilakas. Nakilakas, sir.
Sir, Aris, not Leo.
Hindi siya naririnig.
Aris, not Leo.
Oh, yes. Sir Aris, yan. Naririnig ka na namin.
Sir, regarding lang sa
Mahangin yata sa lugar mo ah.
sorry. Nasa opisina kasi.
Okay.
Regarding sa
In English.
Yes, regarding Ohm's law, you are discussing more on Ohm's law, correct?
I am
ng
discussing. Actually, we are already finished Ohm's law. We are applying Ohm's law now.
I'm applying Ohm's law. Are we going to discuss also regarding different theorems like Norton, superposition, method?
Actually, nagsisimula pa lang tayo. We are just on an initial stage in studying electricity.
Okay, sir. Kasi
Our time frame here is around 2 years. Aris. This is a long journey. This is not a review class.
Okay.
Actually, for review class, we have some lecture. You go to the playlist. You have to go to my YouTube channel. Then you just click the playlist. I have some lecture. Not complete subject, but there are some lecture of some review subject. This is already finished in my, this is circuits part 1 is already finished. But that is a review class. A review class is different from a college setup, just like what we are doing here. This is a college setup. This is a standard third-year college setup. First, we will go to third-year subject. The second, we'll go to fourth-year subjects of electrical engineering. And then the last, we'll go to fifth-year subject. Okay? We will compress the 3 years in electrical engineering to about 1 year. More than 1 year. Maximum of 2 years. That is our time frame, Leo. Ay, Aris.
Okay, sir.
Okay.
Thank you.
Wala ka bang tanong tungkol sa lesson?
Naintindihan naman, sir. Nakakasunod naman kasi. Kaya tinatanong ko lang.
English.
Want to ask, I just want to know, sir, if we can also use other theorems to solve those equations.
We are
like
not yet there. We are not yet there. Maybe you are you have already some knowledge, no? You are on a review stage. What course are you? Are you BSE graduate or ETF also or what?
Pareha, sir, I'm a graduate ng BSIT, electrical. Tapos kumuha rin ako ng ETF kasi 4 years lang yun nauna.
Ano ETF mo? EE rin?
Oo.
Graduate ka na. Are you graduate?
Yes, sir.
Okay. Kaya pala eh. So may mga alam na kayo. Alam nyo, gusto kong, hindi naman sa ano ha, okay lang kayo nandiyan dyan. Alam nyo, mas gusto kong umattend dito yung mga first year, second year na estudyante. Even high school or senior high. Gusto ko sila umattend dito eh. Kahit first year sa EE, second year sa EE, third year sa EE, yan ang mga magaganda dito eh. Na umattend sila. Graduates, nasa review stage na kayo. Pero gusto nyo mag-refresh kayo, okay yan.
Tapos
Yung sa ano medyo
already
problema lang
finished,
natin
sir,
yung mga nag-ETF program. The problem there is the mathematics and engineering science.
I already finished, sir, 1 review center. This is my second.
Okay. What can you say about our, what is your comment na lang? Can you give your comment on what we are doing right now?
Yes, as you
Speak
mentioned,
in English.
sir. Yes, as you mentioned, this is the first review center.
Can you remove your kasi ni-remove mo kanina eh. Can you remove your mask? Okay, what is your comment of what we are doing here?
It's I think this is the best, sir, because comparing to other review center, you are the first one that gives a live and a pre-webinar, which you can actually interact with the students.
Okay.
So this is the first time that I saw, because most review center they will not give it for free.
Yes, definitely.
Yes.
In a scale of 1 to 10, how much grade you will give to us?
In the scale of 1 to 10, sir, I will give you 11.
Wow! Di kita
No,
binayaran ha.
that's,
Baka sisipin nila, binayaran kita.
no, no,
Ha?
no. It's because the way that you teaches it, it's not, it's from the basic. It is simple and
Yes.
really and very easy to comprehend.
Yes.
Compared to the other, they will just show you a video and tell you this is. It's not like that. We are learning from you from the basic, so it's very easy to comprehend. Even a first year student will be able to understand what you are teaching.
Yes, thank you.
Then
Thank
that's
you
very
very
good.
much. Thank you very much, Aris. You have a very good,
Yes.
well, you can also speak English well, ha?
I'm working here, sir, as maintenance superintendent here at
Yes,
Saudi
yes.
Arabia.
Thank you, thank you. Thank you, Aris. We'll see each other again. Maybe, I hope, you enroll to our review center. Are you already
Already
REE?
done.
Not yet.
Already
Are you
done, sir.
REE?
Not yet.
Not
Not yet.
yet.
Already done. I already enrolled.
You are already enrolled with us?
Oh yeah, I've already finished one. Then I already enrolled again to you.
Okay. Thank you. Thank you very much. Thank you very much. Okay, let's
Okay,
hear.
sir.
Okay, thank you. Thank you, Aris. I appreciated. Okay.
Yes.
I would like to hear to maybe Sir Garcia. Do you have any question? Sir Garcia, do you have any question or comment on what we are doing right now? Our Filipinos and non-Filipino audience are viewing us. They are watching us over the Facebook live. Ilan ba ang nakikinig sa atin sa Facebook, anak? Andiyan, mamomonitor naman natin. Makikita mo ba? Okay, sir. So, ano po ang inyong masasabi dito? Ay, hindi natin marinig. Tayo, unmute, sir. Pwede ba tayo mag-unmute? Unmute mo si sir.
Yes, sir.
Sir, naririnig na kita. What can you say?
Yeah. Actually, it's good for me because when we studied the ETF program, we did not tackle the algebra, the other lower mathematics. We only study on the advanced mathematics, and
Oh, that's very hard.
it's hard for us to understand. So we need to refresh ourselves so we can go step by step to understand all what we need to understood, and to prepare ourselves for the board exam licensure.
Sir,
Hopefully,
what can you say about what we are doing here?
yeah, sir. Actually, I've been commenting on our group chat and on our it's good, sir. I learned much for this program, sir.
Okay, thank you, Sir Garcia. Okay. So, for those who studied the ETF program, I suggest you go over with the YouTube tutorial. Okay? Because sometimes if you just read books, no, after around 30 minutes, you feel sleepy. Okay? So, it's better to watch YouTube tutorials. We have Filipinos they have their own YouTube channel. You watch them. Okay? Many Filipinos discussing this mathematics, engineering sciences. That's why hindi na namin ginawa muna yon, no? Inuuna muna namin yung EE kasi napakarami nang gumagawa ng mathematics. Dami na po. So many people are doing a mathematics lecture video. In YouTube there are only two purposes for of any YouTuber. What are these two purposes? Basically, number one is to entertain, and number two is to educate or to teach. So we belong to this, of course, the second one, to teach, to educate. Okay? We are not here to entertain, although sometimes we're giving some entertaining words. But maybe you would see me maybe sometimes singing. Okay, so I'll be doing some vlogs, no? We have planned about that, no? We have planned of doing some vlogs. Okay. So, wag muna kayong aalis, yung mga nasa Zoom class, magpapaalam lang ako sa Facebook Live. To all our friends in our Facebook Live, thank you very much mga kawerpa. Maraming salamat po sa inyo. Pansamantala po titigil muna tayo sa ating ginagawang ito. Maraming salamat po. God bless you all and stay safe mga kawerpa.